Okay, good morning everyone. We can start the session. Today we are discussing about the important questions from this chapter, magnetic effects of electric current. Okay, so I hope everyone went through this chapter. Okay, you know the basics of this chapter. Okay, so but still here in this chapter we are discussing about the magnets, okay, and how they can create the magnetic field around the current carrying conductor. Okay, so here if you have a textbook with you, you can keep your textbook ready. Okay, so whenever required I will ask you to read that part. Okay, so basically magnets are always dipole. Okay, di means they have a two poles. Okay, this is north and this is south. If you cut it vertically in two parts, again, if after division you will get again what, two magnets, and that two magnets are also having what, two poles. So always whenever you are cutting the, again suppose if you are cutting this, again here two short magnets are formed, again they are having what, north and south pole. So whenever you are cutting the magnet vertically, always you will get what, the dipole. Okay, and magnet is divided into number of small parts, and whenever you are dividing, always you will get the two poles. Okay, two poles, that is north and south. That's what. So that is the reason magnets are known as what here, dipoles. Okay, monopole never exists in the magnets. Very important. Monopoles are never exist in the magnet, but there would be always two poles are there. So we know that this all basic. We learned this in 7th standard also. Suppose here we have a like poles. Okay, I brought both like poles. Suppose here I have a north, here south, and another magnet I have, and here north, and here what, we have a south pole. So when I brought two like poles near to each other, that time they repel. Okay, that time they repel with each other, and whenever I brought unlike poles, okay, means one is north, another is south, and another magnets south I brought it near to the north, then there is what, attraction. Then there is what, attraction. Very important. Okay, so from this we can conclude, whenever there is a like poles are there, suppose north and north are in front of each other, or south and south are in front of each other, then they always repel. Okay, and whenever there is a unlike poles like south north or north south you are bringing together, then there is what, always attraction. Very important. Okay, so now here these magnets having some characteristics. Okay, and the magnetic field lines are also produced when we are using this. So here when you suspend this magnet freely, okay, then always it shows the north and south direction. Always it shows what, north and south direction. So this is nothing but what, the basics of this magnet. Okay, so first property what we learned here, from this what we can say, that properties of the magnet. So magnets are always dipole. Dipole means they are always formation of two poles, north and south. If you cut it into the two parts, again there is generation of two poles only. So monopoles are never exist on this earth. So always the magnets are dipole. Whenever you are suspended freely, so it always shows north and south direction. Like poles are repelling and unlike poles are what, attracting. So these are the characteristics, or we can say that properties of the magnet. Okay, so any other properties you know, and from this we can, and even the magnetic substances, or the magnetic substances are having an ability to attract, okay, some ion particles or ion filings towards each other. Okay, so whenever we have to discuss now, whenever the current is flowing into the any conductor, and if you are bringing the magnetic compass, okay, magnetic compass near to it, so this magnetic needle is showing what, the deflection, As it is bringing near to the wire, it shows more deflection, and you are taking that back, then showing what? Less deflection. That means what? Whenever the current is there in any conductor, so there is what? Generation of the magnetic field. Now what do you mean by magnetic field? Magnetic field is nothing but what? Imaginary field, where if you are keeping any substance, that substance is what? Means that substance where the force is exerting on it, okay, due to the magnetic field. That is nothing but what? Your magnetic field or space, okay. So here the magnet, this magnetic field is measured in terms of Tesla, okay. So this is what? Measured in terms of Tesla, capital T we are denoting. And then magnetic field lines always shows the magnitude and direction, and the magnetic field can be described with the help of magnetic compass. For our class 10 we are showing magnetic field with the help of magnetic compass only. You can just take a screenshot, we will go for the next part. Okay, so from here only that field lines also we can discuss, so that part is also getting over. Suppose if I have this magnet with me, so always remember the magnetic field lines are arises from north to south externally, and internally they are going from south to north. So like that they are forming, they are going towards the south, okay, outside. So these are nothing but what? Here the magnetic field lines, okay, which are going from north to south, okay, externally, and internally they are traveling from south to north, okay. So these are the magnetic field lines. And magnetic field lines, one more time I will explain you. So magnetic field is nothing but what? I will explain you one more time. Wait, I will check. Yeah. So here I'll erase this. That is the experiment which is given in your textbook, for this, to check the magnetic field. In exam they will ask, what do you mean by magnetic field, and how can you show that there is a presence of magnetic field, okay. Explain with the help of circuit diagram or explain with the help of diagram, okay. So I will here explain. Suppose here we have any component, and here I kept a voltmeter over here, and here I have an ammeter. Then here I kept one paper, okay. Here I kept one sheet cardboard, and here battery supply is given, and here we have a key, okay. So now initially the key is open, okay, and I will take this as a XY conductor. This is current carrying conductor, this is total conductor. I just inserted the cardboard paper over here, okay. So before starting of this experiment, I will explain you how the magnetic field is generated, okay. So if you take any current carrying conductor, okay, current carrying conductor means what? A wire. In that wire current is flowing, so this is I is the current. Can you getting this? So whenever there is a flow of current from, suppose I will write here X to Y, current is going from X to Y, and I shown this with arrow. So if I have a magnetic compass with me, okay, so I brought that magnetic compass. Compass is somewhere initially here, okay. This magnetic compass is initially somewhere here. So slowly I started bringing that compass towards the conductor. Then what will happen? So whenever this compass comes over here, okay, so the magnetic needle is what? Started deflecting. So why? When we kept here, that time it was not deflecting, okay, it was at the rest condition, because there is a no magnetic field, okay. And here slowly I am bringing over here, now it is started deflecting, okay. As I bring it over here, then this needle is deflecting at a higher rate, okay. So deflecting at a higher rate. So that means what? Whenever the current is flowing from one end to another end, then there is a generation of the magnetic fields. See, these are what? A circular magnetic fields. So how much amount of current you are flow means you are allowing to flow from this conductor, according to that it can generate what? The magnetic field. And if you are keeping anything into this field, that object can experience the force. Okay, that means this field is what? Exerting force on that object. Very, very important. So whenever this compass needle or that magnetic compass you are keeping here, it shows the maximum deflection. Okay, because it senses the magnetic field. Again, if you are taking this magnetic compass away, okay, away from the magnetic field, then slowly its deflections are what? Reduces. Okay, deflections are what? Becoming less. So from this we can say that the magnetic field we are representing by the letter B. Okay, its measuring unit is Tesla T. Okay, but magnetic field we are representing by letter B. So as we are bringing the magnetic compass near to the current carrying conductor, that means it shows the more deflection. And when we are taking back or away from the magnetic field, then it shows what? A less deflection. That means from here we can conclude this magnetic field is inversely proportional to the distance r. Can you get it? So here the distance between the current carrying conductor and field, distance between current carrying conductor and the compass is reduces, then magnetic field is what? Effect of magnetic field is more. Okay, distance of the current carrying conductor is more, between the current carrying conductor and compass is more, then magnetic field is what? Less. This concept is very, very important. If your magnetic field and magnetic compass is both are away, okay, then magnetic compass is not in the field of in the magnetic field, then there is a that means that distance is more and magnetic field is less. Very important relation. B is inversely proportional to R. B is a magnetic field and R is the distance between them. Okay, magnetic field and magnetic compass. Can you getting up to here? Can you getting? Okay, this is very, very important. So now we can go for this experiment. Okay, so suppose here we have a iron filing. Okay, randomly I kept over here and they are arranged randomly. Okay, so this is the battery B and now key is closed. Whenever key is closed, current is flowing through this. Okay, whenever current is started flowing through this, then they all are arranged in the circular manner. They form what here? Loop. Okay, that means the particles are what? Started attracting and they are what? Forming here that circular loops over here. Okay, so now if I bring magnetic compass over here, then it shows the more deflection, and if I am taking away, then it shows a less deflection, because no force is acting on the magnetic compass needle when you are taking back, and when you are bringing near to it, that means the magnetic field is what? Exerting a force on it. Okay, this is what the concept, how the magnetic field is varying to the distance. This is what the experiment. Can you getting? 100% 3-mark question will be come on this experiment. Okay, getting this? Okay, so from this we can give the characteristics of the field line. Okay, you can take a photo, write down the relation between B and R. Write down the relation between B and R. Now next is we are discussing about the characteristics of the field. Okay, So magnetic field, what are the characteristics of the magnetic field? Very important part. Sometimes they will ask you to write the characteristics of the magnetic field. 3 mark question will come, or maybe they will ask reason or assertion, or in MCQ also they can ask. So field lines also are always arises from north to south pole from the magnet. Very important. Field lines are always arises from north to south externally, and internally they are going from south to north internally. Okay. So this is what first property. Second property is nothing but what? The field lines are closed curves. These are nothing but what? Closed curves. This is second, because you can observe here they are going from north to south and again from south to north. That means they are what? Forming the curves over here. Then next one is field lines are closer. Okay. Suppose any object, or we can say that field lines are more than magnetic, then the magnetic field intensity is more. The magnetic field intensity is more. Okay. Then fourth one is field lines are away or apart. Okay, are apart, then magnetic field lines intensity is less. Okay, that I will show you. See here, if I have the magnet over here, look at here. So suppose I have a magnet over here and field lines are very close to each other, very close. That means they are more crowded. More crowded means there is a more magnetic field, or intensity is what? Greater in that area. But as we are going away from the magnetic field or from the magnet, then these lines are what? There is a space in between two magnetic field lines. If more space, then magnetic field is what? Becoming less and less. Okay. So this is nothing but what? This is also one characteristic of this field line. Can you getting this? If field lines are closer, then they form a more magnetic field. If magnetic fields are away from each other or apart from each other, that means the magnetic field intensity is what? Less. Can you getting? And now the direction of the field lines. Okay, field lines always gives the direction. Okay, very important. Field lines gives the direction of north and south poles. North and south poles. Okay, this is also one property. Then next one is, so direction inside the, that we already discussed, and very important property of the magnetic field line. So magnetic field lines are never intersect. Never intersect. Very important property. Many times they will ask the reason on this. Okay, why they are not intersecting. So whatever is the magnetic field, okay, just now I told you field lines are very close to each other, then magnetic field intensity is more. That means here more crowding is the magnetic fields, but they never intersect. Okay, they can form the loops, but they never intersect. Because why they are not intersecting? Suppose if I draw a tangent to the magnetic field line, so that tangent gives the direction of magnetic field always. Okay, and again someone draw the tangent like this and this, then it gives two direction, which is not possible in the single plane for the magnetic field lines. That's what these field lines never intersect. Okay, so whenever we are drawing a tangent to the magnetic field lines, then in two different directions, then it always gives the two different direction in the single plane, which is not possible, which is not valid. That's what here the magnetic field lines never intersect with each other. It's very important. Okay, so these are the characteristics of the magnetic field lines. So characteristics of magnetic field lines. You can take a screenshot. These all are very important characteristics. What we discussed, they can always form the curve, closed curve. Magnetic field lines internally they are going from south to north, externally they are going from north to south, and then magnetic field lines are very close to each other, then their magnetic field is more. Magnetic field lines are apart, then their field intensity is what? Less. Then magnetic field always gives the direction of north and south poles, and magnetic field are never intersect with each other. Okay, so this is what, these are the characteristics of the magnetic field lines, very important. Okay, take a screenshot. Getting this? I'm just giving idea, and after that we can do the discussion. Okay. Getting? Chalo. We can go for the next part. So that is the right hand thumb rule. So why these thumb rules and all is given? Okay. So here we have, see, the magnetic fields, they are forming close curve and all. But if a normal observer, people like you and me, if we want to find out the direction of magnetic field, then how to find out the direction? Is there any notation? While traveling also, we are always checking the directions or maps on the Google. So similarly here, the magnetic field lines, whether they are really going from north to south or internally they are going from south to north, we have to check it. So how can we check the field direction? Okay, if we want to find out the direction of the magnetic field lines, then we are always going for a right hand thumb rule. Very important, right hand thumb rule. Okay, now I know everyone is having right hand with you. Okay, so here I have a current carrying conductor. This is X and this is Y. Now current is going in the upward direction. Okay, current is going in the upward direction. Take your right hand, okay, keep it like this. Then your thumb, okay, that thumb you can keep it in the direction of current. Current is going in the upward direction. Okay, and curl your fingers. Okay, so my fingers are going inward to the board. Okay, so inward means I will show here cross. Okay, they are going in and coming out from this side. Can you getting? So this is cross is for inward and this is for outward. Okay, and now current is going in the upward direction. So can you able to check according to your right hand rule? Is it correct? So if I see with the help of marker also I will show you. So current is going in the upward direction. So I will keep the thumb in the direction of current and the curl fingers are showing what? Magnetic field line. So it is going in and coming out from this side. Okay. So here the direction of the magnetic field we can say that perpendicularly inward to the board. Okay. So now someone will ask me now, okay ma'am, current is now going up. If current is going downward, okay, if current is going in the downward direction, this is Y and this is X. Then again you have to take your right hand only. So keep a thumb in the direction of current. My current is going in the downward direction. Now curl your fingers. So here it is going in. Okay, so I will write with another pen. So from here it is going in and it is coming out. Can you getting this? Okay. So from this we can conclude that right hand thumb rule, whenever we are keeping our right thumb in the direction of current, then curl finger gives the direction of magnetic field. Okay, I will repeat one more time. Whenever we are keeping our right hand thumb in the direction of current, then the curl finger shows the direction of magnetic field. Okay, I will give you one task now. So try to find out the directions. Okay, this is one conductor AB. Current is going in this direction A to B. Then another conductor, so where the current is flowing from B to A. Find out in and out. That means direction of the magnetic field. Okay, I will give you 1 minute. Check what is the answer. Understood? No? Right hand thumb rule. Who is getting the direction? They can type the message. Check whether if people are getting the directions or not. Yes, getting the directions. Check you all are getting the directions. Okay, I will write here. Check with me. Okay, accordingly, current is going from A to B. So thumb showing the current and curl finger. Here cross and here dot. Okay, now current is going from B to A. Then place your thumb in the direction of current. Now we are going in and we are coming out. Now check the answers with me. Verify the answers with me. Check. How many people are having got the correct answer? Getting this? Okay, getting the answers? Okay. Now, very important thing, that is, I hope everyone understood the right hand thumb rule. Okay, now we can discuss about the factors affecting magnetic field of a circular current carrying a conductor. So first, already I told you the magnetic field is affecting due to the distance. Okay, if distance is more, magnetic field is less. If magnetic field is more, that means distance is very less. So we just now did B is inversely proportional to the distance. Okay, so B is nothing but what here we can write it as magnetic field. Okay, we can write it as magnetic field. There is an inverse proportion between field and distance. If distance is more, magnetic field is less. If distance is less, then magnetic field is more. This is one. And magnetic field, okay, whatever is the magnetic field, the same amount of current will that means whatever the current passing through the conductor, according to that the magnetic field is generated. Okay, more is the current, more is the magnetic field. More is the less is the current, then less is the magnetic field. Okay, as well as this magnetic field depends on the number of coils or number of turns, we can say that. Okay, so more is the turns, then magnetic field is also what? More. Okay, so these are the factors which are affecting the magnetic field lines. Can you getting? Then after that we have to discuss about the solenoid and all, but at least I hope everyone understood the basic concept of this chapter. Okay, there is one more of magnetic field, means how to find out the force on the on an object due to the magnetic field. So here I will show you. Here right hand thumb rule, we are actually getting we are calculating the direction of the magnetic field from the right hand thumb rule. Okay, right hand thumb rule gives what? Right hand thumb rule. Thumb rule gives the direction. Okay, it gives the direction of magnetic field. Okay, there is left hand rule is there. Okay, that is also known as a Fleming's left hand rule. That is known as what? Fleming's left hand rule. There was a scientist, okay, who discovered this Fleming's the left hand rule. So Fleming's left hand rule we are actually using to find out the force. Very important. Maybe they will ask, Fleming left hand rule gives what? It gives the direction of force. And right hand rule, what it gives? It gives the direction of magnetic field. This is magnetic field, not magnetic force. But Fleming left hand rule always gives the direction of force. Okay, direction of the force. So what the magnetic Fleming left hand rule? So if we have so whenever we are taking the left hand and we are taking this thumb, index finger and middle finger, they are always what, mutually perpendicular with each other. This thumb is perpendicular to this index and this index finger is perpendicular to the middle finger. This thumb is also perpendicular to the middle finger. So whenever we have these three fingers, with these three fingers, if we are holding mutually perpendicular to each other, then always this thumb gives the direction here, mother, father and child. Here this gives the magnetic field, this gives the force and this gives what, current. So this is what, current, okay, and this is the force and this is what, the field. So these are what, three fingers. With the help of that we can find out the direction of force. So whenever application comes, I will explain that. So these are the factors affecting the magnetic field. Take the screenshot of this and then we can start the question answers. Okay. So write down first question. Write down first question. List 4 properties of the magnetic field lines. List 4 properties of the magnetic field lines. List the 4 properties of the magnetic field lines. So everyone knows, everyone can type one property. Chalo, fast. What are the properties? Just now we discussed, no? They can form a curved loop. The magnetic field lines externally they are moving from south to north and internally north to south and internally they are going from south to north. Okay, they forms the closed curve. Then more is the field number of field lines are more. That means electric field intensity is also more. If less they are apart, then there is a less magnetic field. Okay. Then we discussed they form the closed loop and they are forming, if you are suspended freely, then always gives the direction of south and north. Okay, and these dipoles are what, never intersect. If they that means they are giving two different direction on the same plane, which is not possible. Okay, so these are the what, properties or characteristics of the magnetic field lines. Write down next. I will not explain this is in detail because already we discussed this. So these are the important, that's what I am asking you to write down. Okay, write down next. State any two factors. State any two factors on which the magnetic field produced by current carrying straight conductor depends full stop. Second sub question, mention the rules which helps to find the direction of its magnetic field. Mention the rule which helps to find the direction of its magnetic field. Okay, so here they are saying state any two factors on which the magnetic field produced by a current carrying straight conductor depends, and second mention the rule which helps to find the direction of its magnetic field. So here first they are asking state the two factors on which magnetic field is produced. So what are the two factors are there? Just now I told you, magnetic field depends on the current, how much amount of current is flowing, the same amount of magnetic field line is produced. See, you can see on the board, okay, magnetic field is directly proportional to the current and magnetic field is inversely proportional to the distance. If number of turns are more, then magnetic field is also what? More. Okay, these are very important part which I covered today. And next one is what? They are asking the direction of its magnetic field. So magnetic field we can find it out by using right hand thumb rule. So writing only right hand thumb rule which gives the direction of magnetic field, only writing this you will get entire 1 mark. Okay. So from this can you clear it? What is, who will give the direction of the magnetic field? Right hand thumb rule. And who will give the magnetic force? Fleming's left hand rule. Getting understood? So note it down, and then I hope everyone noted the question. So now write down next question. Write down next question. A metal rod PQ is placed in the magnetic field. A metal rod PQ is placed in the magnetic field. The ends of the rod are connected. The ends of the rod are connected with the battery using wires. Full stop. Where will the rod move? Okay, so they gave a diagram over here. So I am taking some application based question today. So please prepare this chapter. This chapter is very easy, okay, and mostly 7 to 8 mark questions on this. So don't leave, because no numericals are involved in this chapter, but all conceptual based question they will ask. So here diagram is given. This is what the rod given. Okay, this is what the rod, and here they connected the battery. Okay, this is what they connected a battery. Here we have a positive and negative. So this is the terminal P and this is terminal Q. And now here magnetic field lines are also given. So these are what? The magnetic field lines. Okay. So this is what the magnetic field lines are given. And they are asking us to find out the direction of, they are asking the ends of the rod are connected with the battery using wires. Will the rod will move? Okay. Where will the rod move? They are asking. Okay. So PQ is a rod. Now how can you find out? They are asking different question. No, just now I told you how to find out the direction of magnetic field and force. But they are asking different only. The metal rod PQ is placed in the magnetic field. The end of the rod are connected with the battery using wires. Where will the rod move? They are asking where will the rod move? Okay, maybe sometimes for this question they can give options like into the field, upward, downwards, out of the field. Now here what? See, from due to this circuit, current is flowing in this direction. Okay, these are all green color lines are nothing but what they are saying, the magnetic field. This is nothing but what? Magnetic field lines. Very important. Okay, so people are thinking, okay, these are the lines they are considering, and there only they are applying the right hand thumb rule. Not required here to apply the thumb rule. Thumb rule apply where? So current is flowing from positive to negative, means current is flowing in this direction. And whenever you are applying right hand thumb rule, so here what? It is cross and here what? Out. That means this is inward and this is what? Outward. Okay. But now the problem is that the rod will move where? Okay, rod will move where? That is very important. So how can you find out? And they are saying magnetic fields are what? In the upward direction. See, the rod is like this and magnetic fields. Okay, these all magnetic fields are what? Going in the upward direction. Okay, so what will happen? The magnetic field is going in the upward direction. That means they are what? Applying the field on this rod, no? So field is applying on the rod, then rod will move away, or we can say that out of the field. It will go out of the field, because the force is exerting on this rod, so this will go what? Out. Okay, so we can say that this will go out of the field. Okay, so write down next one. Write down next one. An electron enters a magnetic field. An electron enters a magnetic field at a right angle. At a right angle. At a right angle. At a right angle to it as shown in figure, as shown in figure. Okay, draw this figure. Okay, this magnetic field line, green color part which shows the magnetic field lines, and there is a electron. Okay, electron whose direction is this. Okay, draw this. Okay, an electron enters in a magnetic field at a right angle to it as shown in figure. Okay, so they are asking the direction of a force acting. The direction of a force acting on the electron will be. The direction of force acting. The direction of a force acting on electron will be first to the right. First to the right, B to the left, B to the left, C out of the page, C out of the page, D into the page, D into the page. Okay, now check how can you find out. Just think, use here, they are asking here the direction, correct? They are asking what here? They are asking the force they are asking. The force they are asking means we have to use a Fleming's left hand rule. Okay? What is the Fleming left hand rule? Take your all the three fingers, first three fingers of the left hand, thumb, then index finger and middle finger. Middle finger always gives the current, the index finger gives the field, and thumb gives the motion. Okay? Yes, where you are getting which option is correct, into the page, out of the page, to the left or to the right. Okay, check what you will get the answer. You can take the right thumb rule, left hand thumb rule. Fleming's left hand rule. Then check. Is anyone got? Check. Here the current is flowing, correct? So current flow is nothing but what? Movement of the electron, no? So electrons are constituting the current. And here remember this middle finger shows the direction of current, okay? Then this gives the index finger gives the direction of a field, okay? Field is going here and the direction of current. You have to keep these fingers mutually perpendicular with each other, and here this gives the direction of what? The this motion. This is nothing but what? Motion. So as electron is going in the downward direction, then it's we are taking the force is directed which is opposite in the direction of electron travel into the page, because they are saying it's a electron enters in the magnetic field at the right angle. That is, right angle means what? It makes a 90-degree angle over here, okay? It makes the 90-degree angle over here. If you take your Fleming's left hand rule, then force is what? Going into the page, okay? So this constitutes the current is going downward, okay? And this is what? The magnetic field, and this is nothing but what? Force. So here if you apply Fleming's left hand rule, you will get the answer this into the page. It is going into the page. Okay, so check here like this, you will get, okay? Now next question. The resultant magnetic field at point P, write down next question. The resultant magnetic field at point P situated midway between two parallel wires, situated midway between two parallel wires, placed horizontally, each carrying a steady current I. Write down the option. Current I is in the same direction as the current in the wires. First option, in the same direction as current in the wires, same direction as the current in the wires. Second, in the vertically upward direction, Next option 0. Okay, and last option, in the vertically downward direction. Okay, I will repeat this question. The resultant magnetic field at a point P situated midway between two parallel wires placed horizontally, each carrying a steady current I in the same direction as the current in the wires. In the vertically upward direction. Second option 0, and in the vertically downward direction. They are asking here what is the resultant magnetic field at a point P, okay, and P is kept in between wires AB and CD. Okay, then what you can do here? So here very important, the charge P, very important, the charge P is kept at middle. So here the direction of CD in the current is flowing from C to D and current is going in AB is from A to B. So you have to take your right hand thumb rule. You can apply. So if I keep my right hand finger, okay, in the direction of current, then what? Here curved finger, this is going in and this is coming out. So similarly, if I keep a right hand thumb, the curved finger gives the direction of the magnetic field. So here if I am keeping, again it is going in and coming out. So this is going in and this is what? Coming out. Now forget about the outer part, the in between AB and CD. So this is one is what? Going in, and another is what, coming out. Then same amount of current is flowing in between them, and they are what, equally spaced. Why? Because P they are saying at the midway. Okay, so here one is acting inward and another is acting outward. So magnetic force, or the at point P, the current is nothing but what, here you will get 0. So because of this direction, suppose if this direction is reverse, then in that case you are getting here dot and here you are getting cross. That means here you will get the maximum current. But here direction of current is what, same in the both the wires. So the current acting at point P is nothing but what, 0. Okay. So here the resultant magnetic field at point P is also 0. Write down. This is the answer. So option C is the correct answer. You can apply the concepts properly. Okay, now one more question is there. Write down. Name the poles P, Q, R, S. Name the poles P, Q, R, S of the magnets in the following figures. A and B. In the following figures A and B. And B part, write down. State the interference drawn. State the interference drawn about the direction of magnetic field lines on the basis of these diagrams. Very IMP question. So this kind of questions mostly they will ask. Okay, so here they gave this as a P and this as a Q. Okay, and they gave the loop like this. Okay, and they gave the direction on these field lines. Okay, and this is figure A. And here they gave figure B is nothing but S. Okay, so this is what the diagram given. From this they are asking us to find out these points P, Q, R and S. Okay, now can you find out here? So check, always check the arrows. This is going from P to, this is going from P to Q. This is going from P to Q. Can you getting this? Okay. Then so this part you can remove, but here the field lines are going from P to Q. That means P is nothing but what, your north pole. Okay, and Q is nothing but what, your south pole. Okay, so we got half for figure A. Then in second figure, if we take the figure R and S, so the field lines are going from R to S. Okay, in both the cases, see, R to S. Then these field lines, they are not showing any arrows, no, so no need to consider. Okay, so here also see, they are giving out, then they must go here, no, so they are not coming here. So here what, from Q it is going out and from P it is also going out. But we have to take only these loops. Okay, so these loops P to Q, that P is nothing but north and Q is nothing but south pole. Understood? Okay, then we have another, that is figure RS. Okay, R we have to find out. Again here R is nothing but what? The field lines are going from R to S, then R is again your north pole and S is nothing but what, your south pole. Can you get in this? Understood? Okay. So now they are saying second part, state the interference drawn about the direction of the magnetic field lines on the basis of the diagrams. So here if you check both the diagrams, I told you the outermost directions of the field lines are different. Okay, that means always remember they are emerging out from the north and they are emerging out from the south. That is the meaning. Okay, they are emerges out from the P and emerging into the Q. This is the meaning, that only they are expecting. That's it. Okay. Write down next question. The figure shows two magnets. Write down. Next, this is a final question. After that, we can do it. The figure shows two magnets X and Y. The figure shows two magnets X and Y kept near each other. Kept near each other. Kept near each other. Full stop. Their poles are not marked. Their poles are not marked, but the magnetic field lines are shown in the figure. But the magnetic field lines are shown in the figure. Okay. Figure. Write down. Question is not yet completed. Write down. If magnet X is moved, if the magnet X is moved towards magnet Y, towards the magnet Y, as indicated by the arrow, as indicated by the arrow, comma, will the two magnets attract, will the two magnets attract or repel each other? Will the magnets attract or repel each other? Question mark. Justify your answer. Justify your answer by describing how. Justify your answer by describing how you intercept the field lines. How you intercept the field lines. Okay. So intercept the field lines. So here figure is given. Okay. So here they gave, that is X. Okay. And field lines. Okay. Then this is what they gave here. X moving towards Y, and here figure is given, this is Y. Okay. And the field lines, the arrows are going in. Okay, so how can you justify here? Okay, so here check, as X is moving towards the Y, here direction of the field lines in this, and their directions are what? Going in this direction. That means maybe here this pole, this pole and this pole may be like, okay, and the poles are what we are bringing together, like poles we are bringing together. That means they are repelling with each other. Okay, so this is what the answer. Here we can say that in this figure magnetic field lines are going towards, you can identify here, you can write down like this P and Q, and here you can write R and S. So in first figure, in X magnet their field lines are going from Q to P, and in here in figure B the field lines are going from R to S, which is exactly opposite to the X. That means maybe Q and R are the like poles, and always there is a force of repulsion in the like pole. This is the answer required. That's it. Okay, this kind of figures they will ask. Actually, in short, I can say that the paper is application oriented. You should know the concept and you should have to apply that concept. Okay, that is important here. They will ask one more question. Student want to use an electric heater and electric bulb and electric fan simultaneously. How should these gadgets are connected with the mains? Okay, justify your answer giving the reasons, and they are asking sub question, what is an electric fuse, how it is connected in circuit. So a student want to use electric heater, bulb and fan simultaneously, means at all the times. Okay, always remember at domestic purpose we are doing all the connections parallelly. Okay, I want, but someone in the same room don't want the light, or in the another room that another student is there but he don't want a light. That means if one in series, if suppose the connection is in a series, then it is very difficult. Okay, that means if you turn on somewhere, then all the lights will glow, but whenever the connections are in parallel, then we can only on in that particular room. Okay, so here the first answer, all the appliances, all the electrical appliances are will get the same potential difference, and they all are connected what in the parallel. Okay, and here they are saying fuse. What is an electric fuse? And electric fuse, what is the electrical fuse and how it is connected in the circuit. Electrical fuse is also connected, okay, in a parallel only. Okay, so electric fuse is a wire, okay, where the excess amount of current is flowing through the circuit, then it is what started melting, as it is having no melting point. Sorry, sorry from my end. Here electrical fuse is also connected in parallel, as the fuse is having very low melting point. Suppose excess amount of current is flowing through the circuit, then it is what started melting, and once it's completely melt, it disconnects the supply. That means there is a short circuit. Okay, so this is the use of fuse. So basically to avoid the this thing excess current, or due to avoid the damage in the appliances, we are using what fuse. Okay, this is the fuse. Getting this? So remaining questions I will post it on the group. You can prepare that. Okay. So I covered few questions, not all. Okay. If you want, I will cover later. Okay. I will message you accordingly.